Okay, in chapter 5, we're going to cover two sections, section 5.2 and 5.5. And we'll start with 5.2 today. So 5.2 is going to be solving multiple equations at once. And so this is called a system of equations. And so we're given an ordered triple, and it's going to be x, y, and z. So this is a point in three-dimensional space, so this is difficult to draw. Basically, you have the two-dimensional Cartesian grid, and then you overlay onto it another axis, and if you can imagine this, this would be x, y, and then z. So if we were to plot this point, it's 3 in the x, minus 1 in the y, and then 4 in the z. And so you have to basically go 3 out in the x, but then you have to go back, you have to go along the y-axis, so minus 1, and then you have to go up the z-axis until you get to 4, where that would be lined up. So it's somewhere in three-dimensional space, say maybe right there. But again, it's really hard to represent a three-dimensional point in a two-dimensional piece of paper or screen. Okay, so we have to think in 3 dimensions here. In fact, in 2 dimensions, we've seen this. If you have x and y, and you have 2 lines, let's say one line looks like this, and that's governed by y equals mx plus b, and then you have another line, let's say it looks like this, and that's also y equals mx plus b. The point that is a solution to both of those lines is where they cross. So this xy would be a solution to both of those equations. Now in 3 dimensions, it's really a plane, so it's a whole, like a flat piece of paper. So you can imagine you have 3 flat pieces of paper, and kind of how they cross is what's going to be the solution to the system. So 2 planes, when they cross, let's see if I can show this. Let's do it like this. So right here, this finger right here, there's a line that's formed there. There's a line that's formed. That line would be where the 2 planes cross, but then I don't have another hand. If I have another hand, and then a 3rd plane would cross through those 2, it's going to cross through that one line. So that one line where they touch, the 3rd plane is going to go through that line at one point. So we have one point will be the intersection of these 3 different planes. And again, it's really hard to explain, and it's hard to show without some sort of computer graphic or something like that. But these first couple problems, we don't really need all that. All we need to do in the first couple problems is plug in these x, y, and z. So first we're going to call this equation 1, equation 2, and equation 3. And we're just going to replace all x's with 3. We're going to replace all y's with minus 1. And we're going to replace all z's with 4. And what we're going to see is if we get the equation to balance. So we should get number equals number itself. So let's try equation 1. We're going to plug in 3 minus 1 and 4 into equation 1. So we would have x is now 3, y is minus 1, and z is 4. So we get 3 plus 4 is 7, minus 1 equals 6, 6 equals 6, it checks out. So that point, that ordered triple, checks out for equation 1. Now we try equation 2. X is 3, y is minus 1, z is 4, does all that equal 1? Well, we're going to get 3 plus 2 minus 4. That's 5 minus 4. That's 1 equals 1. Checks out. Now we try equation 3. X is 3, y is minus 1, z is 4. Does that equal minus 1? We're going to get 6 plus 1 minus 8. That's 7 minus 8. that's minus 1 equals minus 1, it checks out. So because this point makes all three equations balanced, it is a solution of the system. Now, if any one of those equations failed, so if I got 7 equals 5 or 3 equals minus 2, something like that, then if any one of the three breaks down, then the whole thing breaks down, and you would say it's not a solution to the system. Problem 2 is exactly the same. We have the ordered triple 3, 2, 1, which is alphabetical, x, y, z. So anywhere we see an x, we'll replace it with 3. Anywhere we see a y, we'll replace it with 2. Anywhere we see a z, we'll replace it with 1. So let's do equation 1. X is replaced with 3. Y is replaced with 2. And notice there is no z. That's fine. So it's missing a letter. That's not a problem. We just won't plug a number into that slot. So we'll get 3 minus 14. Does that equal minus 11? Yes. So 14 taken away from 3 is negative 11. So that checks. Equation 1 checks. Try equation 2. 4 times x, where x is 3, plus 9 times y, but y was 2. No z. Does that equal 30? 12 plus 18. 12 plus 18 is 30. So this one also balances. Okay, equation 3. We have no x's. 5 times y, but y was 2. Plus 9 times z, but z is 1. Does that equal 19? We get 10 plus 9. That does equal 19. So this one checks, and therefore this ordered triple is a solution to the system. So that one's going to work also. Okay, 3 and on is where it's going to get more interesting, because now they don't give us the point to check. We have to find the point. So they've given us 3 equations, 3 unknowns, and we have to find the one ordered triple, the xyz number, that satisfies all equations at once. So it's going to be a solution to all of them. So we're going to start by labeling this 1, 2, and 3. Now, what we're going to try to do is, our goal is to eliminate variables. Okay, so our goal is to eliminate variables. And our rule that we're going to use is we can multiply or divide any equation by any number except 0. So we're not going to use 0. Equation by any number other than 0. And then we can add or subtract any two equations. And it really just takes some getting used to. So we're going to look at each of these things, and our goal is going to be, okay, I want to get rid of letters, and I'm guided by, I can add or subtract any two equations, and I can multiply any one equation by any number I want. So I can double everything, I can triple everything, I can take everything times a half, which would be really dividing. The key is you have to do it to everything. So if I multiply equation 1 by 5, I have to multiply everything in equation 1 by 5. So I'd make it 5x, 5y, 25z, and negative 130. So you have to do it consistently to every term in the equation. Okay, so if we look at problem 3, what we're going to do is we're going to notice that if we take equation 1 and we make equation 2 negative, I can eliminate x and y. So what we're going to do is we're going to say, let's take equation 1 and subtract from it equation 2. Actually, let's do that a little differently. I want to always be adding, so I'm going to add minus 1 times equation 2. So let's write equation 1. It's x plus y plus 5z equals minus 26. Now, I'm taking minus 1 times everything in equation 2. So instead of x, it's minus x. Instead of y, it's minus y. Instead of 3z, it's minus 3z. And that's going to equal positive 18. So notice I flip the sign on each term in that equation. And now I add straight down. X's cancel, y's cancel. 5 minus 3z is 2z. And minus 26 plus 18 will equal negative 8. Okay, and then we can just divide both sides by 2, and we'll get 1z is equal to negative 4. And that's going to go right here. So these blanks are z, y, and x, alphabetical order left to right. Okay, and we've got a letter. So we've got a number for a letter. That's always our goal. Okay, now that I know z, I want to go back to my original equations, and I want to combine them in such a way that I eliminate a different letter, but I keep z now, because if z goes away, it's okay, but if I keep it, it's fine too, because I have a number for it, so I can replace it with a number. So let's try to take 2 minus 3, and we'll get rid of x again. So you have to use different equations now. So we'll take 2 plus negative 1 times equation 3. So equation 2 is x plus y plus 3z equals minus 18. Negative 1 times 3y times equation 3 would be negative x plus 2y plus 3z, and that's going to now equal negative 9. And if we add these straight down, we'll get 3y plus 6z equals negative 27. We know that z is really negative 4. So this is 3y plus 6 times negative 4 equals minus 27. This is 3y minus 24 equals minus 27. Add 24 to both sides. 3y would equal minus 3. Divide both sides by 3. Y is negative 1. And now we can plug these two letters into any of the original 3 equations. So we're going to look at them. I might go into maybe number 2. Number 2 looks like it's pretty simple. It's just an x and a y plus a 3z. So it's maybe not as complicated. So we're going to do, we know y is negative 1. We know z is negative 4. And we're going to put those into equation 2. So what do we have? We have x plus y, but y is minus 1, plus 3 times z, but z is negative 4, and that equals minus 18. This would be x, this would be minus 12 minus 1 is minus 13. Add 13 to both sides, x would equal negative 5. Okay, and if you check, you can check this if you want. You would put this ordered triple into the 3 equations like we did in the first 2 problems, and you will get minus 26 equals minus 26. You'll get minus 18 equals minus 18, and you'll get 9 equals 9. So it will check out. I'm going to skip that step just for the sake of time, but you could check it if you wanted to make sure that those 3 numbers are correct. Okay, so that's how you do number 3. Okay, now in problem 4 and all these problems, there's technically an infinite way to solve these, because you could multiply by 10 or multiply by 5, or you can do anything you want and you can get to the same result, but we should still get the same 3 numbers to work. So it takes a little practice because you can do so many different things. There's almost too many options because we might all start these problems differently. Now, one thing that grabs my attention is whenever I see 2 letters that are nearly the same, it's even better if one's minus and one's plus. I'm going to immediately say, hey, let's try to eliminate those 2 because they're so close I can just subtract them and they'll go away. So that's one thing I tend to look for. So let's label these 1, 2, and 3. And I might say my first step would be take equation 2, add to it negative 1 copies of equation 3, and that will get rid of y. So we start with equation 2. X plus 2y minus z equals minus 6. Now negative 1 times equation 3, I'm going to flip the sign on all these things. So 2x becomes minus 2x. Positive 2y minus 2y. Minus 3z plus 3z. And negative 11 becomes positive 11. Okay, now we can add straight down. This would be negative x, y's go away, plus 2z equals 5. And now we're going to call that equation 4. So we still have two letters, and we're trying to get down to one letter equals a number, so I'm just going to write this as a new equation. We've made progress because we got rid of one letter, but we're going to have to do more work to get rid of, to get these down to one letter instead of two. So now what do? Now we look back at the original three equations and we pick a different set. So I can't use 2 and 3 again, but I could use 1 and 3 or 1 and 2. So I can't use 2 and 3, I just did. Let's use a different set, and I have to eliminate the same letter. So look back at 1 through 3. Don't use 2 and 3 again. I just can't use them together in one combo. I can use them separately, so I can use 2 and 1 or 3 and 1, but I can't use 2 and 3 again. And I have to eliminate y again. Okay, so those are the sort of steps you're going to look at to do. And you can do those steps every time. Pick a letter, eliminate it from two equations. Now pick two different equations, eliminate the same letter. So we're trying to get rid of y. Well, let's take 1 and 2, and let's do double 1, and then we can add it to 2, and we will get the two y's to cancel again. So let's double 1, add it to equation 2, and that should eliminate y again. So let's see, doubling 1 would give us 12x minus 2y plus 4z equals minus 30. Okay, equation 2 is unaltered, so we just write x plus 2y minus 1z equals minus 6. When we add this, we'll get 13x's. Y's cancel as designed. We'll get plus 3z, and we'll get minus 36. And we'll call our equation 5. And now we have to combine 4 and 5 in a way to eliminate one of these letters. And there's lots of ways to do it. I'm going to kind of pick up on the fact that we've got a positive 13x and a minus x. So if I can get a 13 in front of that minus x, when I add the 13 and minus 13x, they'll cancel. So that's what's going to guide me. So I'm going to say, let's take 13 copies of equation 4 and add those to equation 5 unaltered. So I'm going to take 13 times everything in equation 4. So it's minus 13x, it's minus 26z, and it's going to be minus 65. I didn't do minus 13 though, so this should have been plus 26, and this is plus 65. I started switching the signs. Be careful there. I did not switch the signs. Then, equation 5 unaltered was 13x plus 3z equals minus 36. And we're going to add those. The 13x's will cancel. 26 plus 3z is 29z, and 65 minus 36 is 29. So these problems tend to have nice even numbers, whole numbers. Divide by 29, z is simply 1. Okay, now I'm going to take this and plug it into either 4 or 5. I have a choice here. But 4 or 5 are down to two letters, and one of them is z. So if this is called back substitution. So if I back substitute, so working backwards to 5, 4, and then eventually to 3, 2, and 1, we can solve for the other letters. So I look at the two equations and I say, okay, 5 has a lot of numbers in it, big numbers, 13, 36. Equation 4 just has minus 1, 2, and 5. Those numbers are smaller, probably easier to work with. So I'm going to pick 4. Let's plug z equal to 1 into 4. So from 4, we have minus x plus 2z, but z is 1. And we're saying that has to equal 5. So minus x plus 2 equals 5. Subtract 2 from both sides. Minus x equals 3, therefore positive x equals negative 3. now we're going to plug x equal minus 3 and z equal to 1 into any of the first three equations. So either 1, 2, or 3. I'm going to pick 2 again because it looks pretty simple. So x, which is minus 3, plus 2y, we don't know what y is, minus z, z is 1, equals minus 6. So this would be 2y minus 4. And then we'll add 4 to both sides. 2y is minus 2. Therefore, y is minus 1. And we had solved the three equations, three unknowns. We found the order triple. That would be a solution to all three simultaneously. And again, the steps are pick two equations, eliminate one letter. Pick two different equations, eliminate the same letter. Then those resulting two equations you can solve for one of the letters and then back substitute. But I know we're going to need some more before you're able to do this. This takes practice for sure. Okay, 5. Let's take a look. So notice none of the x's match, none of the y numbers match, none of the z numbers match. So no matter what we do, we're going to have to take a multiple of some of these equations to get them to match. Now notice this. This 3 can easily become a 6, and this 3 can easily become a 6. So if we can make those 6 x's and 6 z's, we can maybe combine them and maybe lose two letters at once. So let's try that. So let's write, first off, that this is equation 1, equation 2, and equation 3. Okay, let's try to double equation 2 and add it to negative 1 copy of equation 3. So let's double equation 2. You get 6x minus 10y plus 6z equals negative 94. Now negative 1 times equation 3. So just flip the sign on all the terms in equation 3. Plus 4y minus 6z equals positive 70. And now we add. The x's will cancel. 4 take away 10y is minus 6y. Z's cancel. And 70 take away 94 is minus 24. And we can divide both sides by negative 6 and get y is equal to 4. So in this one we got lucky. We were able to get two letters to go away in one shot, which is very nice. Okay, now we are going to look at, okay, let's try to eliminate another letter. And we might say, let's see here. So we know what y is. So if we can get rid of z or x, we will be able to isolate another letter and should be easy to solve. So what I did was I said, let's take 3 times 1 and plus 5 times equation 2, and that's going to allow us to eliminate z. So 3 times 1 would be 15x plus 9y minus 15z equals 21. Now 5 times equation 2. 15x minus 25y plus 15z equals negative 235. So 5 times negative 47 is negative 235. Add these. 30x's minus 16y, z's go away, equals minus 214. Okay, but we know what y is. Y is 4, so let's replace that. And we're going to get 30x minus 64 equals minus 214. Add 64 to both sides. 30x equals minus 150. And this is again where I said these tend to be nice whole numbers at the end. Divide by 30, x is negative 5. Okay. So not too bad. The numbers got a little big on that one, but we could still handle it all right. Okay, now we're going to plug x equals negative 5 and y equals 4 into one of the first three equations. And I would probably go with equation 1 because the right-hand side is the smallest number, maybe the easiest to work with. So let's put it into 1. So it's going to be 5 times negative 5 plus 3 times 4 minus 5 times z. Z is the only one we don't know, equals 7. Minus 25 plus 12. So minus 25 and 12 is minus 13. Add 13 to both sides. Minus 5z equals 20. Divide both sides by 5. Z, negative 5. Z is negative 4. Okay, and we were able to get the ordered triple. That one, we're able to eliminate 2 letters at once, and then pick 2 more equations. Eliminate one of the letters. Didn't really matter as long as we kept y and one other letter. We could solve for the unknown second letter, and then take those 2 variables, plug it into one of the first 3 equations, solve for the third variable. Okay, so in problem 6, again, you want to jump, your eye will hopefully start to jump to stuff like this. We have 2 variables, one's minus, one's plus, they have the same number in front, it's 1. So if we simply add equations 2 and 3 together, we will get rid of a variable. And that's always our goal, is to get rid of a variable. So let's take 2 and just add it right away to 3. So we'll get x plus y minus z equals minus 8. Equation 3 is 3x plus 5y plus z equals 0. And when you add these 2, we'll get 4x plus 6y, z's cancel, equals minus 8, and we'll call that equation 4. Okay, now, notice that our 2 letters are x and y. And also notice that equation 1 only has x and y in it. In fact, we can look at equation 1 right away. If I can make that 2x a negative 4x and add it to equation 4, I will eliminate x. So let's right below this write negative 2 copies times equation 1. So I'm going to take everything in equation 1 times minus 2. So we'll get minus 4x, we'll get minus 2y, and we'll get minus 4 times minus 2 is positive 8. Add those. You'll get 4y equals 0. Divide both sides by 4. Y is 0. So 0 divided by any number is 0. So y is 0. Okay, so now we know y. So now we're going to pick any other 2 equations and solve for either x or z. And I picked equation 1 and equation 4. Well, we just did that one. So now we look at, so because we know y, we can easily plug this into 1. So we don't have to do as much work as I thought. Just plug this into equation 1. Equation 1 says 2x plus y, but y is 0, has to equal negative 4. So 2x has to equal negative 4. Divide both sides by 2. X equals minus 2. And now we can just go back to any 3 equations. So let's go x equals minus 2, y equals 0, and let's plug those into, I have to pick one that has z in it because that's the last letter we don't know. And again, it kind of looks like equation 2 is a little simpler. So x is negative 2, y is 0, minus z, and that has to equal negative 8. So add 2 to both sides, we'll get minus z equals minus 6, and therefore positive z has to equal positive 6. And that will be the solution for problem 6. So one of the big challenges here is there's so many different ways to go that students tend to almost get decision paralysis because they're not sure what to pick, where to go. And so your guiding essence is just trying to get rid of a letter. So you see those 2 z's, they're opposite, they have the same number in front, just add them and get rid of them. You might have also looked at 1 and 2 and said, hey, I can get rid of y right away. So there's more than one way to do it, but eventually we should get the same result. Okay, problem 7. I'm going to kind of just show you the easiest way to do it. Again, there's more than one way. But I'm going to see that 3x and that x, and I'm going to say, let's get rid of those 2. So let's take equation 1, and let's add to that 3 copies of equation 3. So equation 1 is minus 3x minus y equals minus 2. Tripling equation 3 will give us positive 3x minus 6y plus 3z equals 15. And when we add those, we will get negative 7y plus 3z equals 13. Okay. Now we're going to notice, okay, this equation, which we would call 4, has just y's and z's in it. But equation 2 has just y's and z's in it. So if I take 7 copies of equation 2 and add it to this, I will get y to go away. In fact, let's write that. Let's write 7 copies of equation 2 and write it right below this line we just wrote. So 7 times y would be 7y. Minus 4 times 7 would be minus 28z equals minus 63. And when we add that, the y's will cancel. This will be negative 25z equals negative 50. Therefore, z is equal to 2. Okay, so right away we got a letter solved, which is great. And now we're going to plug this into equation 2, and we'll get another letter. So if I take that into 2, we have y minus 4 times z, but z is 2, has to equal minus 9. Y minus 8 equals minus 9. Add 8 to both sides. Y is negative 1. And now we can take y is negative 1, z is 2, and plug those into either equation to solve for x. I would probably go with equation 1 because there's not even a z in that. So it would be minus 3x minus y, which is minus 1, has to equal negative 2. Minus 3x plus 1 equals minus 2. Subtract 1 from both sides. Minus 3x equals minus 3. Divide both sides by minus 3. X is 1. And that would be the ordered triple solution for problem 7. Okay, problem 8 is going to be a parabola, and we're given 3 points, and we're going to try to solve for the parabola given these 3 points. So we have minus 1, minus 7. We have positive 2, negative 16, and we have negative 3, negative 11. So let's use color here. Let's call this, this is the x and y for point 1. So minus 1, minus 7 with a dot here. We have minus 2, minus 16, x and y. So positive 2, minus 16 is a point down here. And then the final point, minus 3, comma 11. Now this is not drawn to scale. But basically we're going to say that there is some parabola that's going to come and go through these 3 dots. So there's some parabola that's going to go touch each of these dots, and we have to solve it with those 3 points. Okay, well, we're going to plug those points into this equation. So this is the general form of the parabola. Y equals ax squared plus bx plus c. But we're going to place each x with the first number and each y with the second number. So let's keep the color theme. I'm going to replace x with minus 1. So it's going to be a minus 1 squared plus b times minus 1 plus c. And that's going to equal y. So I'm moving the equation y just so it looks more like the other equations we saw. Y is negative 7. And so over here I'm going to write the equation. It's going to be negative 1 squared is just 1 times a is just a minus b plus c equals minus 7. And that's now equation 1. Okay, equation 2 will look like this. a times, now x is 2, so 2 squared plus b times 2 plus c equals y is minus 16. And if we expand that out, we're going to get 4a plus 2b plus c equals minus 16. Okay, the last one, replace x with negative 3. Equals negative 11, the y term for the third point. And expanding this out, we'll get equation 3, which says 9a's minus 3b's plus c has to equal negative 11. Okay, now that setup's done, now it's no different than the other problems, but now we're working with the letters a, b, and c. So we have to take multiples of these equations to try to solve for one letter at a time. So I'm going to say, why don't we take equation 1 and subtract equation 3 from it? So I can easily eliminate those c's. So let's take equation 1 and subtract equation 3. So we're going to get a minus b plus c equals minus 7. Equation 3 is 9a minus 3b. We're subtracting, so we're adding a negative copy of equation 3. So this is actually minus 9a plus 3b minus c equals positive 11. Minus 8a plus 2b, c's go away, and this would now be 4. Okay, and we're going to call that equation 4. And we can also take equation 1 and add to it negative 1 copy of equation 2. So equation 1, a minus b plus c equals minus 7. Negative 1 copy of equation 2, so we're going to make everything negative, or switch the sign. Minus 4a minus 2b minus c equals positive 16. This would be minus 3a minus 3b, c's go away, equals 9. Okay, and we'll call that equation 5. And now we are going to say, let's take 3 copies of equation 4 and add to it 2 copies of equation 5. That will now allow us to eliminate b. So 3 times equation 4 would be minus 24a plus 6b equals 12. 2 times equation 5 would be minus 6a plus, minus 6b minus 6b equals 18. Add those. Minus 30a, b's go away, and this is 30. So therefore, divide by negative 30, a is negative 1. And now our life's going to be a lot easier because we can back substitute. So let's plug this into 5 and solve for b. So let's do that up here. Minus 3a, but a is minus 1, minus 3b has to equal 9. This would be positive 3 minus 3b equals 9. Subtract 3 from both sides, minus 3b equals 6. Therefore, 1b is equal to minus 2. Okay, and now we can plug this into 1. Let's say it's the simplest one. So let's take a is minus 1 and b is minus 2 and plug those into equation 1. Equation 1 says a plus minus b. So minus 1 minus b, which is minus 2, plus c has to equal negative 7. This would be minus 1 plus 2 plus c equals minus 7. This would be 1 plus c equals minus 7. Subtract 1 from both sides. C is negative 8. So the last thing to do is to put these letters in for these numbers in for the letters of the original equation. The original equation was a, which is minus 1 times x squared, plus b, which is minus 2 times x, plus c, which is minus 8. So if you were to plot that parabola, that quadratic equation, you would get a parabola that has those specific 3 points on it. And we have solved the problem. And that concludes section 5.2.